Did you find the papers?
No.
That's unfortunate.
I'm just gonna have to.
Excuse me while I juggle my own skull.
Okay, so here's the deal. So I have
Papyrus?
no idea what happened to the copies, and nor do I have. It's just bizarre because they're gone and sort of the originals. So
There's a black hole.
Well, I bet you
could
can
have.
find a bone that he
okay,
cut.
so Ryan,
Sorry.
everybody hears exactly what you're saying
Okay.
in the state. Don't.
Okay, I'll stop.
Okay, so here's the setup. This is what I would give you on the piece of paper that I ran off yesterday, which I can't find. So you've got two charges here, Q1, and this is actually Q2, and then you've got a third charge up there. And so this is the magnitude on this first charge, and these are in coulombs. And then you've got this one, 1.0 times 10 to the negative 6. So first question is what charge does this charge have to have and this charge have to have so that this charge up here only has a force acting on it. The net force of this is acting in this x direction. So that's the question. What would have to be these charges so that the net effect of these charges only produces a force in the horizontal direction? Bruce, what would the charges have to be? So here's Q1 and there's Q2, okay? And this is you know that this one up there is a positive value. So the force up there is a positive charge, okay? So the question is that what are the charges on Q1 and Q2 so that the net effect of those charges produces a force pointing to the left? No, they have to be positive or negative.
Positive or negative?
Yes, so that's what you're trying to figure out, is what are the charges on these down here so that the net effect of that is pointing to the left?
Q1 is negative and Q2 is negative.
You're saying Q1 is going to be,
Negative,
yeah, and Q2 is going to be,
positive,
why?
because negative attracts to this way, and then since if we make that negative, then that force, the net pull would be negative, meaning to go that way.
Okay, so let's try.
It makes sense in my mind.
It does, and I like it. So if you're saying this one is negative, this one is going to have a force pulling this way, right? Okay, true?
Yeah.
And then you're saying if this was positive, then
Yeah.
that force is going to tend to drive this one in this direction. True?
Yeah.
Okay?
Just a weird question. Why do we measure charge in coulombs and not amperes?
Because that's, the coulombs is just the fundamental unit of charge.
Amperes is French and we don't like them.
Well, amperes measures current. This is just,
Coulombs is technically amperes per second.
I don't think that matters.
current is amps per second. Coulombs is just coulombs. It's the fundamental unit of charge. Current is, no. So you got a force driving it this way. You got a force driving it this way. Basically, what Bruce concluded is that the y component are going to cancel each other out, right? And then the only thing you have left are the two x components, which are going to drive it this way. Cool with this?
Yes.
Okay, so that would have been the first question. Now, here's going to be the next thing. If you had the actual drawing. So this is 4 meters, and this is 3 meters. Here's this charge, this is negative, it's positive. So the next thing that you want to find is the actual value of this force. Okay? So here's what I want you to do. We're going to stop that camera in just a second. So here's the next thing. This is one of the most fundamental things you have to do with fields and forces to be able to work this in terms of triangle. So you've got, this is separated by 4 meters. Here's Q1, 4 times 10 to the negative 6. Here's Q3, 1 times 10 to the negative 6. This is Q2, 1.7 times 10 to the negative 6. So what you want to do is actually calculate the value of that force. And this is technically 4.0, so that we have the same number of significant digits. So this is a 37-degree angle. This is a 53-degree angle. So that makes that a right angle. So what you want to do is to be able to calculate the magnitude of this force right there. So here's your numbers, 4.0 times 10 to the negative 6, 1.7 times 10 to the negative 6, 1.0 times 10 to the negative 6. Bruce was right. That's going to be that bottom left is a negative value, and that bottom right is a positive value. So go try and find the value of the force.
Alrighty.